Okay, so welcome back. We're going to be solving another question from the first chapter of the engineering mechanics textbook by Meriam, and in this one, we need to determine the angles made by the vector v, which has x and y components with the positive x and y axes, and we need to write the unit vector n in the direction of the v. So for finding a unit vector, we solved a lot of these types of questions previously in the channel in 3D questions. But in this one, for the concept of the unit vector, all we need to do is just to find this ratio, which would be the vector over the magnitude. And we can also write the unit vector in another format, and that would be cosine of theta x I plus cosine of theta y j. And in 3D question, it will be cosine of theta z k, which ijk is the unit vector for x, y, and z components. But since we have a 2D question in here, we only have I and j, so there's no k. We should be able to find this pretty easy. So let's start with the vector v. So this part of the unit vector, so we're gonna have minus 36i plus 15j, and for finding the magnitude or the denominator of this ratio, we simply have the square root of 36 squared plus 15 squared, and again it will be the same for 3D questions too. So we're gonna have z squared in here, which we have 0 in here, so it will be the same in 2D and 3D. We just have one more component in 3D questions. So that's how we find the I and j. So for I, we're gonna have minus 36 divided by square root of 36 squared plus 15 squared. So that's going to be minus 0.923. That's our I component. And for j, basically have the same thing. We just have 15 instead of minus 36. So this is going to give us plus 0.385j. So as I mentioned, this part is equal to cosine of theta x, and this will be equal to cosine of theta y. And theta x and theta y is basically the angle with the positive x-axis, angle with positive y-axis. So for finding the theta x, we basically have cosine inverse of minus 0.923, and for y, we're going to have cosine inverse of 0.385. Let's see what we get for each. So cosine inverse of 0.923, we forgot the negative sign. So that's going to be 157.37 degrees. And let's see what we have for the theta y, 0.385. And this is going to be 67.36 degrees. So far we found the unit vector. This was our unit vector. We found the angle with x and y axes. And yeah, that's pretty much everything. And as I mentioned, if you want to find the magnitude of the force, we're going to have the square root of 36 squared plus 15 squared. So this will be the magnitude of our vector v in here, which let's see what we get. And this is going to be 39, which was basically the denominator that we had in here. So that's pretty much everything for this question. That was the first question of this chapter. Let's move on to the second one. All right, so in the second question of this chapter, we need to determine the magnitude of the vector sum of v1 and v2 in here, and the angle theta x, which v makes with the positive x-axis, and it's asking us to complete both graphical and algebraic solutions. So for graphical, we basically need to use either the parallelogram law or the triangle rule in order to find the resultant of these two or sum of these two vectors. So for v1, we basically have the same vector from v1 to v2. So we're just gonna put this in here exactly parallel to what we had, and we're gonna have one same as this one on the other side. So I'm just gonna bring this in here, and the line that connects here to here is gonna be our, and what we can do, we can measure this with ruler, see what we get, and that would be equal to 27. Let's say we measure this with ruler, it's like 10 centimeter, and we just have to do the ratio that centimeter is equal to 27 units, and let's say we get like 50 centimeter for this one, and based on that we can find the magnitude of our v in here. I don't know why I put this. So that's the graphical method, but if we want to find the exact value, what we're going to do in here is that we can use law of sine and law of cosines in order to find the answers. So if you want to do the law of cosine, we can go with one of these triangles in here. So let's consider we're going to go with this triangle, and if we want to find v, we need to figure out this angle in here, which if we just draw one line parallel to our x, this angle is 30 degrees, and this angle here would be what we have in here, which we can find pretty easy if we call this one alpha. Tangent of alpha would be 4/3, so the alpha would be tangent inverse of 4/3. Let's see what we get. So tangent inverse of 4 divided by 3, that's going to be 53.1 degrees. So this angle is 53.1. So we can find this angle here for our law of sine and our law of cosine. So if we want to do the law of cosine, we have v squared is equal to 27 squared plus 21 squared minus 2 times 27 times 21 times cosine of the angle that we just found, which was 53.1 plus 30 degrees. So we can find v in here, which would be actually the square root of what we had in the previous step. So the square root of 27 squared plus 21 squared minus 2 times 27 times 21 times cosine of 53.1 plus 30, and this is gonna give us 32.15 units. So that's the magnitude of the v, and for finding the angle that it makes with x-axis, so we're looking for this angle. But if we do the law of sines for the yellow triangle, we should be able to find this angle. Let's call it beta. So we have sine of beta over the side that is facing that angle. So 21 is equal to, we can use our sine of the 53.1 plus 30, which is going to be 83.1 over our v, 32.15. So our beta would be sine inverse of 21 times sine of 83.1 divided by 32.15. Let's see what we get. So sine inverse of 21 times sine of 83.1 divided by 32.15, that's gonna give us 40.42 degrees, but this is not what the question is asking. The question is asking the angle between v and the x-axis, which would be beta plus 30 degrees. So the theta x would be beta, which was 40.42 plus 30, or it's going to be 70.42 degrees. And yeah, that's pretty much everything for this question. And let's just compare this number with our graphical method. I'm just going to show it in red in here just to compare it. So we have 4 centimeter, that is equal to 27 units. And let's see what we have in here. This would be something like 4.7, and let's see what we get. 27 times 4.7 divided by 4. So that's going to give us around 32 or 31.7, which is pretty close to what we found in here. But again, if you want to find the exact number, that's how we do it using the algebra. And yeah, hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.